tonight, that's something I've been looking forward to. I have one of my keynote speakers here to do a technical AMA about C++ and connected topics. Herb Sutter is with us today. So Herb, what are you up currently with C++? What keeps you up with our language?
Oh, so I have an administrative role where I chair the C++ Standards Committee, which mostly means organize meetings, but I'm very interested in C++ evolution as well. And as I was saying at my talk at CPPCon last month, and I'll be saying again in Berlin, this is really an exciting year, I think, for C++. And I don't just say that every year. It's because this year we started getting serious safety improvements in C++26, and it looks like we're going to get reflection, the first parts of reflection in the next couple of meetings in C++26, fingers crossed, which will be game changing. I mean, I and others have been pushing for reflection in particular for a decade, some longer than a decade, longer than me, like David and Andre. But I really do think that if we can land what we think we're going to land, that's going to define a new renaissance, a new wave of C++ in the same way that C++11 did. Because just looking backward, like we've done several C++ releases, I think by far the most impactful we've ever done is C++11, because that really changed the way, upgraded the way we write code. There were so many broadly useful features that everybody could use every day, like auto, range for loops. Remember, we didn't used to have smart pointers in the standard before C++11, basic things like that, move semantics, lambdas. And I think we're going to see that kind of wealth, I guess is the right term, in terms of what we can do as programmers coming to C++ to write simpler and safer code, starting in 26, and that's going to be the story of our next decade. So I'm pretty jazzed about that and want to contribute to it. And there's other good features too, but like those are two marquee ones: safety improvements and reflection. Are, boy, they're going to really make a difference for us as programmers.
Yeah, that's actually something I thought about. It's like all those big features aiming at 26. How realistically is it that we actually get them all? Or like, I know the story of C++17 and concept being like just missing the train by like one meeting basically.
Well, that's a good thing too. Is that we're on a train model now? So the committee graciously let me arm twist them into going into shipping every 3 years, so we actually have regularity. And since then, compilers have actually been tracking the standard more closely because, well, we actually know when we're going to ship. And so if something doesn't make one train, that's fine. There's another one that's immediately, as soon as it leaves the station, another one starts boarding. And just look at the conformance list on cppreference.com. That's the best place to go. Go to CPP reference, just at the top of the page, click on conformance, and you will see that they don't wait for the next 3-year standard to ship. GCC and Clang have already implemented, for example, 2/3 of the C++26 features. So when you hear C++26, do not think, oh, it's 2024. That's not going to ship for 2 years. And then who knows, 5 years later. No. C++26 features, a lot of them are here today because the compilers are actively tracking even the draft standards, which I think is great. And it's helped to unify the community based compared to where we were like maybe a dozen years ago, where there was a lot more variation in compilers and which feature worked where. It's really come together in a big way.
All right, let's start with audience questions. Sean Baxter has finally written up a proposal to bring borrow checking to C++ to improve safety. What are your views on his proposal, and what approach is CPP2 planning?
So there's a lot there. So first, yes, thank you, Sean, for writing the proposal. That's a big amount of work, and plus to actually progress it through the committee is a huge investment of time that Sean has now started. So thank you, because we can't do anything without a proposal. I think it's interesting and an interesting exploration. There's a lot more detail. I'll point to the CPPCon safety panel that we had, because there was a lot of discussion about this question there, and also in the committee fireside chat, which is already online. There was a little bit there, but we mostly pointed to the safety panel, and that video isn't available yet, but it will be soon. it's really important to explore things. So this work is really important. Sean is brilliant. Like, how many people do you know who've written a C++ compiler on their own, who's not named Bjarne or Sean, basically? So kudos there. At the same time, it's also really important to talk about adoptability. And so it's important to make sure that we find out how to avoid viral annotations, how we have so that you have to annotate the callees before you can use it in a caller, because we know that's a major impediment to adoptability in real world code. We have to make sure that we avoid heavy annotation. So even if it's not in viral, if you have to annotate frequently, then that hinders adoptability in real world code. And so one of the things that I've tried to do in CPP2 is really emphasize compatibility, like things just work out of the box. So example, for safety, for subscript, for bound safety, you can use qt vector, std span, C arrays, and they're just bounds checked when you use them from CPP2 code, because we have the information already in the code, because everybody follows the pattern of for their contiguous containers of making sure std size works. Well, that means I can inject subscript checks at the call site, and I do in CPP front by default. And there's ways to opt out if you're in hot code, of course, but the default should be safety. And so the fact that I can use existing C++ libraries without any change, no annotation, no revving the library, it's not internal in the functions, no ABI issues, they just work when used from CPP2 code and their bounds checked. That's the kind of thing I think is promising. And that is ideal if we can get it. Maybe we can't always get that, but with lifetime, and this is where it comes back to borrow checking. Rust has a great lifetime model, which gives you a borrow checking model, which gives you not just lifetime safety of many kinds, but also thread safety, because you have non-shared exclusive ownership, exclusive mutating ownership, which is great, but it also comes at a cost, right? Even in Rust, where that is native, you write more unsafe code than you do in C# or Java. And that's not a ding, because Rust gives you thread safety. C# and Java give you the ability to write cyclic data structures in safe code without going to unsafe code. So, it's design is a trade-off, and both are safe languages. So I think that it's interesting to see where this goes. But with CPP2, for lifetime, I'm following the model that I still think is very promising, that the C++ core guidelines have already adopted for C++, which is a design I did with the help of many others, that emphasizes lifetime tracking and that already catches many common cases of leaks and dangling. Not all, it's not intended to be formally provable, but many common cases, including changing an iterator, a vector inside a loop and invalidating your iterator. It catches those already without changing std vector, without changing your C++ code. So to the extent that we can do that and maybe merge ideas from those approaches, but really not forget about adoptability and how much can we make work without rewriting your code or updating your compilers or bifurcating the world or annotating a lot, the better off we'll be, because our goal should be to deliver as much benefit as possible to as much code as possible. And as soon as we have to touch the code, that reduces how much positive impact we can have.
That's true. Actually, let's get a question from LinkedIn. Is there a long-term vision for C++? How can you maintain its relevance in the next 20 years?
That's an excellent question. So in terms of what we standardize the proposals people bring. So there is no central design committee for C++. We have a direction group that gives advice, but it's not like a design team at a commercial shop, which has lists of the features we want to build and then goes and assigns programmers. This is a group of volunteers where it's bottom up. That said, many of them have a very good understanding of what C++ needs, what they need for their use. Some of them are users of C++. Some are vendors of compilers who know what their customers' needs and represent those customers. And we have evolution working groups on the language and the library side to have some oversight, and Bjarne and I participate there to make sure that things fit together well. So we can only standardize proposals people bring. So it's not like a top-down design, it's somewhat bottom-up. But we also have a good sense of the design. So in terms of a long-term vision, I don't think you'll find that the same as, say, a product team does, in terms of it being prescriptive, but we can describe what the vision is by looking at what's in the pipeline. And reflection is clearly a major arc. So compile time programming is the arc, and reflection is the current evolution of it. Because as we've been adding more and more of C++ being able to run at compile time, now we have constexpr that works for nearly everything. I mean, even vectors and strings you can, and dynamic memory allocation you can have at compile time. And now we can write that compile time code and use it with reflection to look at the program itself and generate source code itself. So that is, I am convinced, going to dominate the next decade of C++ as we both add more of the feature, implement that feature, because only the first part, we hope, will be in C++26. That'll just be the first part, but also learning how to use it. And that's going to be a wonderful next decade continuation of the compile time programming arc. And I think it's reflection in a way that I don't know, I think may go beyond what any other language does. Like, it's certainly not like Java or C# reflection. Like, Java and .NET reflection are great. Those programmers love it, and we know it's powerful, but it's runtime. It costs you. And so, for example, last time I looked, doing a method call in Java or .NET through reflection was like 3 to 4 times as slow as doing it directly without reflection. C++ is all static reflection. What we're standardizing is compile time, and so we'll have to make sure the compile time stays down, which I'm hopeful about, because it's going to replace some very slow template metaprogramming we do today. So I think we can actually get an improvement in compile time this way, just like we did with constexpr. But the runtime is 0 by default. This is like a 0 overhead thing. So I'm actually very bullish on and excited that we might actually be able to push the boundaries of what reflection can do in computer science, or at least in commercial languages. So it's going to be fun times and very interesting to see.
Yeah, and I think the next 20 years is difficult to as like a time frame. I really like that you address the next decade in your keynote, but like what's beyond the 2030s?
Sure.
What is like 2035 and afterwards will be really difficult to know.
There's a quote that's variously attributed to Yogi Berra and to other people, that prediction is very hard, especially about the future, right? So it's true. But before we leave that last question, one last thing, also improving safety will be important. And so I'm glad to see we're working on that by, for example, in C++26, local uninitialized variables are no longer undefined behavior. That is a big deal. That we're actually taking steps to address safety in C++26, and there'll be more, but that's why I think that's important too.
And one quick IDE question: what is like your favorite C++ editor IDE when not using Microsoft Visual Studio?
Okay, so you know that I should say Visual Studio Code, because they're different things, right? That's actually my real answer. I spend equal amounts of time in Visual Studio and Visual Studio Code, and include those are just the two I currently use. I have used other editors in the past that I'm very happy with, but right now I use VS for development and VS Code for all my test cases and more text editing, Markdown. I'm happy with that. But I know Emacs and Sublime and stuff are great. I'm not telling you not to use them.
Do you use Copilot?
Do I use Copilot?
Yes.
I use ChatGPT directly pretty much.
Okay. Let's do a quick question on C++26. Will networking make it into the next standard?
My understanding is it's unlikely. I don't think it's a hard no, but we need std execution first. That has been approved. Networking will build on that. My understanding is that there are still some questions being discussed about networking. I haven't been following that as closely as some. So there will be other people who can give you a better answer to that. But my understanding currently, because of the dependency on std execution, which just got voted in, and there's some people who still want to do some testing to make sure it stays in C++26, it doesn't get yanked again, and that networking has that dependency. So there's an ordering issue there. I have also heard a concern, this is a general concern, about standardizing libraries where security patches are important. So this isn't about C++ being unsafe or anything like that. This is about any language. Once we put a library in the standard, it becomes, there's like ABI compatibility issues. It becomes very hard to evolve. We can evolve some, like we can add features, but if we put something that we know needs security patches regularly, it becomes harder to patch it if it's in the standard library, which is kind of backwards, because you think a standard feature like networking ought to be in the standard library. I'm not saying it shouldn't. I mean, we're working hard to put it there, but it's one of those real world considerations that's interesting. I think that the committee still is currently working through some of those questions, and it may be that it's totally fine when we figure out how to do it, but you have to make sure that you know, because you don't want to end up shipping something that you can't patch in a certain way when a certain exploit comes along. It's really sad that we live in such a world, but we do.
Yeah, it's something I thought about. When we have networking, we are basically, making C++ code officially with a standard available on the network, and that has far more implication than when, you can do something weird with file system and we need to fix it. But I guess we'd be in a similar situation with file system.
Yeah, similar conversations have happened with file system. And the reality is that C++ code is internet facing, like it already is. But we haven't nailed down and cast in stone the software that thou shalt use on every system to make that happen, and then make it hard to update. So there's just a trade-off there. Like, for instance, C++ was doing threading long before C++ 11. We were doing threading 20 years before the standard acknowledged that threads exist, right? So that's we're still getting the job done, and we're still internet facing, but we want to make sure that we can stay safe. And again, this has nothing to do with programming language safety. The same considerations apply even if you have a fully memory safe language. It's like, how do I patch? That's the kind of thing that we need to talk about, especially since the standard doesn't actually have a first-class notion of what is a library, what is a DLL, like things like that. So we have to be careful to make sure that we can still keep track of keep control of our vulnerabilities and stay safe.
So talking about standard features, it seems like kind of that the Microsoft compiler is falling behind on the newer features, it seems. So do you, what's your comment on that? Like, the other compilers are catching up, and I see that modules are like very, very much.
I mean, I think this is the kind of thing that changes. As you have a race, you have a different leader at different times, and I think that it's great that everybody is racing to do that. So a few years ago, Microsoft actually, which I think actually for the first time ever, was the most conforming compiler, and that there was a lot of celebration in Redmond about that. Our team was very happy about that. Had a lot of work went into that, and was the first to C++20 conformance. Modulo bugs, of course, because everybody has some bugs. And now GCC and Clang have been really aggressively, like I mentioned, look on CPP reference, implementing C++23, and already like 2/3 of the draft approved C++26 features. This is great. Competition is good. So compiler 1 is ahead this year. Compiler 2 is ahead next year. Well, Microsoft has a good history of chasing taillights. We're pretty good at that. So, so I think this is all good for the community. Again, to put this into perspective, back when I joined Microsoft almost 23 years ago now, 22 years ago, conformance started to be important then, right? So that was great. But still, everybody in the world was 5 years behind the standard. Like, none of the Clang didn't exist, of course, but none of the compilers, not even EDG, had implemented all of C++98, mainly because of export, but not just because of export. And it took like 5 years after we shipped C++98 before the first conforming compiler came along. we are so much better than that now, where compilers are arguing about whether they're fully conforming the same year the standard actually ships, which means they implemented before the standard was approved, because it takes time to implement, versus a year or two later. We are in such a better place with everybody tracking closely that leading edge, and it's nice to see them jockeying for position. So I think that kind of competition is good for everybody.
I agree. And I do remember that when C++ 11 and 14 came around, that Microsoft was not ahead in those years. So history is repeating right now. And I'm just happy to see that, features are shipping in every compiler.
A part of me, like speaking as a longtime member of the Visual C++ team, I like this question. Why is Visual C++ falling behind? Because that is a question we never would have had like 5+ years ago. It's like, oh, of course they're behind. They're always behind. It's like, oh, why are they behind? It's like, all right, people expect us to be in front. This is great. So I think everybody is on the same page, and it's a friendly competition among like all the compiler vendors. We all see each other at standards meetings. We all have beers together, and certainly will those of us in present, a lot of them will be present in Berlin, and we'll be having beers at your conference again. Good German beers, and so it's all friendly competition, and everybody's tracking the standard so closely that we can have questions like this. It's great.
True. So we're talking about features, implementations, and roadmaps. So let's quickly jump over to your own language, CPP2. What are like the current plans? What is like your feature set? What you're ultimately planning right now for the closer future, and like, production use? I've seen like you commenting on Reddit about that.
Yeah, I guess it says, like you mentioned, my own language. Well, technically, I guess any syntax is a language, but I do view it as just an alternate syntax for C++. It's tightly coupled with C++ by design. It always compiles to C++, and that's the goal. Like every type function object you write is a C++ type function object with no marshalling, no overheads, no veneers, none of that, no adapters. It just is. But my roadmap there is to use it as a test bed for experimentation. So I'm going to be bringing more standards proposals. You'll see another wave soon from that work, bringing those ideas to ISO C++ in ways that we can adopt. And I've been doing that before. I've had a bit of a hiatus, and I'm going to resume that now. And in my keynote at your conference, I'll be talking again about how I can now write metaclasses already in the P2996 reflection proposals that David and others have done. So it's not just my compiler anymore. I want to be able to write those in standard C++, and maybe they'll be in a different syntax, but CPP2 has tried to help pioneer the way and show it can be done. It already compiles to C++. Hey, and now can we do it in ISO C++ as well? I think is great. As far as production use, I am currently in the middle. I did not know this question was coming today, but just yesterday I opened a PR to switch to Apache 2 with LLVM exception licensing. It's still a personal project, but at least I think it's okay. If people want to try it for commercial use, I'm going to start allowing that with version 0.8 that I'm about to release. But it's still ODOT, and it's still me and a few dozen other folks who are helping. So use at your own risk, and I still consider it experimental, but it's time to switch to an Apache license, and so I'm excited about it. The main difference between CPP2, the main things it's trying to prove out are ideas about safety and simplicity. Many of the safety issues and some of the simplification can be put directly to ISO C++, like metaclasses for simplicity, bounds checking for safety. Those can be directly proposed for ISO C++, and I am committed to doing that because that's where I can have the most impact. There's always going to be way more users of that than of an experimental new syntax, and I want to have the most impact, the biggest contribution possible if I can. Some simplifications can only happen if you actually simplify the grammar. So those ones are dependent on having a simpler grammar in CPP2 syntax.
And I think like when you actually start using CPP2 in production, and taking that code live, that's a bit of building your own adventure, because that's your own private project, and not like, there's no real support for companies in any way available to just except from the community, which has been grown around it.
Well, which is pretty much yes and no. So yes, and which is pretty much the way C++ was in the 1980s. It was Bjarne and his team, and you use it and you can port it to your own system and that kind of thing. However, just like Bjarne in those days with CFront, now with CPP front, you compile to, in his case, to C. In this case, in my case, you compile to C++. So you get working C++ code, and if you're ever not happy with the CPP2 code, you can always throw it away and continue with the C. You haven't lost your investment. You can continue with the C++ code, because it's always standard C++ code. And I bend over backwards to support compilers all the way back to GCC 10, Clang 12, and MSVC 2019. And the only concession I've had to make is that a couple of features that need requires clauses get hit by a bug in GCC 10, but work fine in 11 up. So GCC 10 is the only one where if a couple of features don't work, like forwarding a concrete type as a parameter, but nearly everything does. So if you have a compiler, a C++ compiler that's younger than about 4 years, you certainly could use every feature in CPP2 and then throw away the CPP2 code, and you still got that C++ code that works on all the compilers. And I test with Visual C++, with GCC, with Clang regularly.
All right. Here is an interesting question about the standard library. Should the standard library be split in two parts, one with slow changes and one with fast changes? Like ranges were introduced in 20, but then we added on in 23, and seems like still some features are missed by folks.
Yeah, there's two answers that come to mind. The first is I actually had a proposal about 10 years ago for ABI reasons to have an ABI, to split it into two parts, to have an ABI stable and an ABI unstable version of each type and function. I didn't pursue that, but that was a proposal that I had. As far as splitting it into two parts, I think the thing you will hear most often is, hey, now that we're starting to have package managers, VC package, Conan, does everything have to go in the standard library, or should it just be in package managers? And I think that's really helped, because the main reason you want something in the standard historically has been so that if I write a book or an article, I know the code will work because I'm using stuff that's in the standard, including in the standard library. But now that the package managers are getting more widely available, I can also say, hey, if I want my effective modern C++ book if Scott Myers was writing a new book today, I keep trying to drag him out of retirement, and he keeps pulling back, but maybe you never know. Never say never. Well, he said never, so I should accept that. But I want another Myers book, darn it. But if he wrote another book, then he could easily on page 1 just say, oh, and VC package install these two libraries, and then he can depend on them in the book. And it's easy to get. It's not like in the past where if it wasn't standard, you'd have to Google around for how do I install it on this compiler? What's the configuration? Oh, CMake what? And and just, hey, install this library and then I can use it, is important, not just for using C++, but for even writing tutorials, writing books, and teaching C++. So I think if we split it into two parts, the most likely ones will be on fast ABI and slow ABI, or standard and versus outside the standard but widely available in package managers. I think those are the two most likely useful ones. As far as introducing ranges and then finishing them in 23, that we should continue to do all in one place, I think, or wherever we put ranges, whether it's in the ABI stable or in package manager or wherever, you can still add to it. And we didn't get to views in version 1, we get views in version 2. Like that kind of thing is still fine as we build it out. But ABI stability and in the standard versus a package manager seem like more promising places to slice.
which,
Speaking of ABI.
yes, I have to ask this question. Are there plans to address ABIs with interfaces or other features in C++? And especially, I mean, standard C++, because I know what are the problems with the, use shared mutex because it's better because we cannot change mutex on some platform. So I've seen a proposal, I think, which was around like in 2021, like actually addressing that on the language part. And I just want to know, like, is the committee putting an effort in thinking about this problem and cracking this nut?
So that question is different. I think, yes, everybody's thinking about it. As far as actually doing something about it, I'm not aware of currently in flight proposals. Maybe I'm missing one, though. There are a lot of proposals, currently in flight proposals about this. However, one thing to remember is that, okay, the standard specifies interface, not implementation. So any change that doesn't require a change to the interface is fine. Now, the place where we most often get feedback on, but the interface prevents an ABI change because we have to change the API, is in places, just a couple of places, like Titus Winters mentioned too in Prague 2020 at our meeting. Hashing is one of them, and I forget the other one, but there were, at the time, there were like basically two examples where we really would have needed to change the API to change the ABI. But beyond that, most of the ABI changes that people want to make, and I see this myself here at Microsoft working in Visual C++, don't require changes in the standard. They're owned by the platform vendor. So let me give you an example. So we know we want in the Visual C++ product, we know we want to make RTTI faster. So it's more affordable so that people use dynamic cast instead of, dynamic cast is slow, I'm going to static cast, downcast, and I'm sure it's right. And then we find out about it because they got a CVE, the vulnerability, because they didn't get it right. That kind of thing happens. So we want people to make dynamic cast affordable. And we know we have to take an ABI break to make some of the changes that we would need to make because it would change the object layout. Mm-hmm. That has nothing to do with the standard. The standard says, dynamic cast, go therefore and make it work, compiler vendor, right? But so it's important to remember the ABI is nearly always is always owned by the platform vendor, not by the standard or the compiler vendor. It's the platform vendor. And most of the time, the API in the standard, the interface, sometimes it does, but most of the time it doesn't affect the ABI. And you might remember that until about, I think it was 7 years ago, and I think it wasn't, maybe it's almost 10 years now because it was 2015, I think. Before then, Microsoft broke ABI on every single release on purpose. And so you would, if you had DLLs from third-party vendors, you would have to get updated ones that worked with the newest release of the Visual C++ compiler. And partly we could get away with that because we were only shipping every 3 years at the time, because release cycles used to be longer than they are now. But since 2015, we said, okay, we're going to actually stabilize the ABI for a while. We intended to break it again in 2-3 years. It's been like almost a decade now. It turns out that people depend on ABIs. It gets really hard to break it. That's why GCC and Clang don't. And I gave you one example, RTTI, of a place where we'd like to break the ABI that has nothing to do with the standard. I'll give you one that did have something to do with the standard. The one place where I can remember we did make a change in the standard that changed ABI was when we banned reference counting on std string and basic string in C++ 11. And you know how long that took? It took one meeting or so. There were a few meetings of discussion, but it basically took one vote at one meeting in 2008 to adopt it. It was over 10 years before the last major platform, Red Hat, enabled the new non-copy on write basic string by default in GCC. The standard said, yeah, sure, we're going to make this change. But it took a decade to adopt broadly in the industry, over a decade to adopt on every major platform. Because I totally get ABI is a thing. I think it really has been mischaracterized and blown a bit out of proportion, at least in the sense that it affects the standard, because it does occasionally affect the standard, but not nearly as often, at least in my experience. Like std string, hash, and there's one other example I know of where we'd like to change the API to change the ABI. Everything else you can innovate under the interface. That's why we've always standardized interface and say, go compete on implementation quality, right? It's ABI is owned by the platform vendor. It's usually, which if the compiler vendor is also the platform vendor, then they have that integration, but often they don't. So GCC for a long time implemented two versions of std the old one for ABI compatibility and the new one for C++11, and left it to each platform vendor which one they would turn on by default. And Red Hat didn't turn on the new one by default for a decade, right? So it's the platform vendor who owns the ABI and who has to keep their users working and their libraries linking. So yeah, it's an issue, but it's going to be an issue for every language, and it's the platform vendor that's the layer where it mostly is affected.
Yeah, that's actually an interesting view that the ABIs are actually owned by other people which are outside of our language. And even if we make our language more flexible and better to break the ABI or affect the ABI, it won't help with that issue for the vendors of the compilers. There is a question from LinkedIn again. What is your answer to the growing complexity of C++ to be learned, especially by novices? How would we teach C++, e.g. at the university, if it gets larger and larger?
So that's a good question. So obviously I'm interested in simplicity. And so my answer is not, oh, use CPP2, because that's an experiment that's working. But I think it is trying to show that we can do simplifications. So there's several examples, some of which were pioneered in CPP2 that are coming to the standard or have already come that will make things simpler. So for example, as of C++20, I no longer have to teach writing 6 or 18 different comparison operators. I can write 1 or 2 and the rest get generated. So that's a simplification I no longer have to teach. And I think that when we get reflection, coming back to reflection, and the fact that we can use reflection as I've been showing in my paper P707 and in CPP2 to generate classes, basically to participate, to let you write compile time code that participates in the meaning of classes. That means I can write class foo, and I'm not writing just any class. I'm writing class, and the draft syntax for ISO C++ that SG7 suggested was put something in parens after the class name, the word class. So class paren interface paren foo. Now I'm not writing just any class. I'm writing an interface. So I get public pure virtual by default. I get a virtual destructor by default, non-copying by default. That kind of thing. Oh, I'm not writing any class. I'm writing class paren value paren point. I'm writing class hashable my struct, that kind of thing. Declaring intent and so reflection and especially using reflection to help author classes, I think will greatly simplify how we write classes and write code. And so I'm very bullish on that. I'm also hopeful that it will help simplify our tool chains. So that's something I've talked about in past talks, including last month at CPPCon, and I'll talk about again. I plan to at meeting C++ next month in Berlin. But I think complexity is absolutely something we need to improve, but I think that there are ways that we can make code simpler. If you go all the way back to C++11 with auto, with lambdas, with range 4, those added features to the language, but it also meant my code got simpler because I could say reuse auto for a variable instead of repeating a long complicated type that was inconvenient to type. Stood vector of foobar : const iterator or something. Just like, no, auto iter equals vec dot c begin, that kind of thing. Made our code simpler. Range 4 certainly made our code simpler. Instead of for I equals 0, I is less than size, plus I, and did I check the size right? I say for auto e : vec. For each element in vec, it's declared if I declare my intent. Every single one of those features made the standard bigger because we added a feature, but it made code simpler. And that happens only when the new feature lets you express your intent more directly. And this is really the difference between a super simple language that falls in the Turing tar pit, and then just a language that gets too complex just more than it needs to be, like JavaScript got to, where we had to have a book JavaScript, the good parts, right? To the extent that we add features that directly express intent, you get away from both extremes. You get away from gratuitous different ways to spell the same thing, like some big bloated languages have done, and we have some of that in C++ too. But you get less of that because they're features that really do declare intent to do a thing that the programmer wants to do. And it gets away from the Turing tar pit, where you have to roll your own and do everything by hand, and your code is very difficult to write, to read, and to maintain. So that's why I'm very, very bullish on features that let you express intent, because the more we have those, the more we can ignore some of the complexity that already exists and make our code cleaner.
Indeed. There's a question which I find interesting. In the context of C++ zero-cost abstractions philosophy, how do you see future proposals for making bounce checking in vector or both safe and more efficient?
In that entire sentence, I love the word "in," because to me, it's about making bounce checking for std vector is the goal. In is one way to implement it. Personally, I would prefer not to implement it in std vector, because let's say that we made a standards change to, and this is something I'm still trying to convince the committee about, right? So not everybody is going to agree with me here. This is my opinion, and I'm going to try to convince people. But if we made vector subscript checking happen by putting the check inside the subscript operator of vector, great, we got that. But we have to then wait for the next release of that standard library. We have to worry about potential ODR issues, although usually we'll just pick the right one. But then if we link in objects that have the checked version and the unchecked version, which one do we take? Comdat folding, all that comes in. But that's manageable. But at the end of the day, the big problem with that is now with that work, we've only fixed vector. Now we need to do span. Now we need to do C arrays. Now we need to do cute vector and list and those kinds of things. That's why I'm very pleased with the way that I'm doing it in CPP front, which is injecting the bounds check at the call site. Because in CPP front today, if you subscript any collection, any span, any ranges view, any cute vector, anything that supports std size that's contiguous, subscript is just bounds checked. Std span as is. The GCC one, the Clang one, the libstd C++, libc++, the MSSTL one, all of them are bounds checked today in CPP2 without any library change, with no ODR issue, with no waiting for a new library, and they all work. And it doesn't, because if you make the change there at the call site, at the subscript expression, you don't need to go update every library. And so I'm personally very bullish on that. Plus, one other benefit you get is that, let's say you have two call sites in the same file or in two different files. One you want to be bounds checked, and one you want to not to be bounds checked because it's in a tight inner loop or something, right? And you've proven the bounds are safe, and you've proven the performance matters, so you want to suppress the bounds check. In CPP2, it's easy because bounds checking is on by default, and you just opt out in that one file, but they both use the same std vector. They are one's bounds checked, one isn't. It doesn't matter how you link them together. That's not going to change. One concern I have of doing the bounds check inside vector subscript is, now if I'm in that situation, how do I get that same effect? Because the one translation unit has checking, the one does not. I had better have them be using the same std vector. But are they using the same implementation of subscript operator? If they're both using the subscript notation, that means am I going to now, if I link those together, I can only have ODR, one subscript operator. Do I get the bounds checked one? If so, I'm getting bounds checking in the file that didn't want any. Or do I get the non-bounds checked one? And that way I'm not getting bounds checking in the file that wanted it. So I don't see any way to do it that way without having two APIs that you spell differently, just like we spell subscript and at differently today. And look how useful that is. I view that as a counterexample of usability. It just is. Look at the adoption. It's been there. People have been saying use at for decades. It doesn't happen. And never mind that throwing an exception is probably not what you want to do. So I think the philosophy.
Do you advocate for using at? I mean, it's there, but like.
Yeah, I generally don't, but like it's what we have today. So like if you need, if I'm sure 10 years ago I wrote something somewhere that said if you need bounds checking, use at, because that's what you got. That's all there is in the standard. But I think that the right answer is to integrate it with contracts. So what CPP2 does, actually, it integrates it with contracts, but it doesn't do it by declaring a precondition on every subscript function. Like std_vector now has a precondition. What it does instead is the language says every call site of a contiguous container subscript or contiguous view, anything contiguous. It could be a C array, it could be a acute vector, std vector, std span, std ranges view that's contiguous. Every subscript at the call site is bounds checked, and if you get a violation, the current default behavior is to report a type safety or bound safety violation using the bound safety contract group. Which, if you want to then hook it, you can put in your own, install your own handler for that to integrate with your error reporting system. So all my bounds errors go to my library. That works today, and so I think that's a promising way to do it, and still integrate it with contracts. But this comes back to the question that you had earlier about Sean Baxter's borrowing implementation. I think it's great to experiment with. I'm really worried about all the annotations and that I can't use std_vector unchanged and have lifetime safety. I want to use std_vector unchanged and have bound safety. I've demonstrated a way to do that. It works today, and I didn't have to change anything. And I think that's what's important for adoptability, so people can use it with as least friction as possible, and for impact, that the most possible code gets the benefit of it. And so I think adoptability and impact are very important pragmatic parts of any design.
So yeah, this actually leads very nice on our next question. Like, this fits really, really nicely together. Are like the C++ safety initiatives arriving too late to fend off the growing adoption of Rust or other safe low-level development languages?
Short answer, no. We're moving ahead nicely. I think it's always great to have competition. So thank you, Rust. And Rust is a nice language in many ways. It has some nice properties, especially for thread safety that nobody else has got. Although I know Swift and others are working on that as well. And things like what Sean's doing to say, hey, how much of this can we affordably get in C++ are great questions to ask. But everybody understands, I hope, that even if C++ was the worst language ever, which it's not, and was like that every second line had a security vulnerability, which is nowhere near where we are. Even if everybody wanted to, there's no way that the C++ code in the world is going to be rewritten in another language in our careers anytime soon. We need to help what's there. There is more new C++ code. I haven't run the numbers, but last time I looked, I would be gobsmacked if this was not true. I expect that there is way more new C++ code being written every year than Rust code. Like just new code, never mind all the code that exists already. I remember with one large ISV I went through just a few years ago, and we measured it several different ways. And just the completely new lines of C++ code in their code base, and they cared about safety and efficiency and those things. Just the new, and they were experimenting with Rust, but just the new lines of code, ignoring modified lines, ignoring third-party libraries that they put in, just their own new lines of code, was something like 2 million lines of code a year, just at that one project. And so that's obviously a large ISV, but there's lots of code. But to come back to your question, arriving too late, it's interesting. It reminded me immediately of a quote by Bill Gates, and I'm sure other people have said it too, but he once said that people overestimate what can be done in 2 years and underestimate what can be done in 10 years. And that is really true. 2 years ago, people were finally correctly freaking out about, hey, we need to take safety seriously in C++. Already now in draft C++ 26 as of the March meeting, so this news is now 6+ months old already, we decided that there's no more undefined behavior for uninitialized local variables. We did that. We're doing that, and compilers will implement it. So that's and that there's more where that came from, and we're doing it in an adoptable way that doesn't change the meaning of existing code, right? Because by making that behavior undefined and providing an opt-out to get the uninitialized with an attribute, if you want it, you opt into it. By doing that, we've disturbed no existing code. Just recompile it with a C++ 26 compiler, and it's safer. Is exactly the adoptability story we want. We really, really need to make sure we avoid any adoption friction, especially viral annotation or large-scale annotation or alternative standard libraries or needing wrappers. If we have to do that tactically here or there, we'll look at those cases. But adoption and impact. The more we can do without disturbing existing code, the better. And that's a great model. So I'm really glad to see that we did that already in the standards. So thank you for Thomas, JF, and others who had proposals in that area. Thomas has won the day, and all the people who worked on it. More like that, please. I'm very bullish on those improvements.
Yeah, I think actually that's a good approach to make the language safer, not like have a safety header you need to include to use certain features in a safe way.
Yeah, when it comes to this too, it's not just the amount of code. I am not involved in automotive and life safety directly, but I plenty of my friends are, including Robert Secord, who's now the convener of the C Standards Committee, and he's been at MITRE and CERT and security organizations for a long time. Is now at Woven by Toyota. Which is very interested in life safety for cars and driver assisted and various levels of autonomous vehicles and things like that. Safety is super important. He was making the point in a meeting I was in with him just a few weeks ago, and I think I mentioned this at CPPCon as well in our safety panel, that when it comes to life safety, right now, if you want to certify medical equipment, you want to certify a software that runs in a car, you want to run software that's used in aviation, there is this pile of legislatively required features and tests that you must show that you pass in order to qualify to legally use that software in those areas where they could hurt people, and to certify the software meets certain safety. So MITRE is not MITRE. MISRA is an example of that, but also other kinds of tools to certify software. Today, those certifications are for C and C++ code, which means that even though Rust is a safer language on the tin in terms of language guarantees, C and C++ code written with those tools and that pass those certifications and pass those tools is actually today the safe choice, and Rust is the risky choice, and this is not a ding against Rust. Rust will get there. It'll just, in 5 years and 10 years, it'll have those tools too. But it's just like, oh, let's just write it in a safe language. Well, but what other safeties are you giving up? Because there's other kinds of safety than language safety, in this case enforced by tools. And yeah, that's more expensive, et cetera, but it exists. There's this head start and this ecosystem that exists and works. And anytime you bring up a new ecosystem, it costs you and takes time. So it was a new idea to me. And then I totally understood it, but that, 10 years from now, Rust may not have those disadvantages, and that's great, but we have tooling yet to build out. And I see the same thing on the Visual C++ team where I work, where I've been working, and it now has the Rust team as part of our team as well. So I see those folks regularly, and we have a backlog of things to do for Rust as well. All these tools that exist for C++ but not Rust. Where today, if you want to ship a component in Rust, you have to get an exception to that Wave's running that tool, and so you're taking some risk that it didn't follow that certification, it didn't meet that certification. All this will go away. It's just a matter of time and tooling. You know, it takes a while to catch up with all the ecosystem, and this is what happens when you bring up a new ecosystem. But Rust is a great language. We love it. Don't get me wrong. Just as a practical reality, right now, in 2024, C and C++, yeah, I'm including even C here, which is less safe than C++, are the safe choices for life safety, automotive, aviation, and those kinds of things. Rust will get there too, but it's worth remembering that we run a lot of life safety stuff very well and at high quality in C and C++ today. And we'd love ways to make that cheaper and more affordable and bring more of that safety into the language. So to make it easier.
There's actually a question on it. You mentioned MSVC, etc., but actually there's like the profile plan. So what's the status on profiles for C++? Is it like on the road to 26, 29?
Yeah, they are progressing. I don't know yet that they have a specific landing date, but one of my hopes is I have a profiles paper that I have not written any yet myself, but I have one that I intend to ship next week, proposing very concrete profiles as a starter set. So who knows, maybe those could make a standard sooner than later. But to me, my understanding is that as we standardize profiles, especially to the extent that they are rules for that basically essentially define a subset of the language, I don't see any reason why we shouldn't backport those to make them available either in the standard or in practice de facto in implementations when you're using pre-C++ 26 or 29 conformance modes. So I should be able to run, like the ones I'm going to propose are basically the C++ core guidelines safety profiles, those like a couple of dozen rules near the end of the document that are specifically about the 4 kinds of safety, about safety, initialization safety, type safety. Most of those rules are about code that's legal as C++ 11. I would love to have those profiles enforceable even when compiling in C++ 11 mode or 14 or 17 or 20. So whether the standard mandates that or just implementations do it de facto, either way, I want that to be available to people. So so they're progressing. I'm going to contribute to trying to make them more concrete and to ship them in a standard, but I also hope they'll be available down level because that's how we make it, again, adoptability and impact. We want to make the impact, as much impact as possible to improve the safety of existing code where we can, or even in older, in code bases that have to compile under older standards modes.
True. Another question on things in flight, like tooling in the standard and the tooling group. The Common Package Specification, which looked very promising, seems stalled. Why is tooling in the language not a priority?
That's so I don't know. And the second does not follow from the first. So I think it is a priority in the sense that we have a tooling study group that, to my knowledge, is active. I don't know the details of where the Common Package Specification is right now, so I can't answer that question. I do know we have a tooling study group that is looking at papers at every meeting, as far as I can remember, and so I would ask, say, Michael Spencer, for example, or folks like that, as to as to where that's going. But I do think that there is a consciousness that we need to do more with tooling, like for modules, for package managers, and it's also a hard problem because you have to get vendors to agree, and you also have to meet the real world needs. These are challenging technical problems. So I'm not surprised if they're working through technical challenges like, oh, what do we do in this case? Like especially with modules with an exported template, what do we do in this case? If we want to communicate what the C++ source of truth says to a module system or a build system or a package manager.
That's true. What do you think about SRD execution? The API changed a lot across papers and quite a lot of work for implementers. Yeah,
so we voted that into draft C++ 26 at our June, wait, I'm already losing track of which month things are in. Yes, the June meeting, the most recent meeting in St. Louis, which is exciting. I know there were concerns still expressed about, oh, well, what about performance and build times and other things, where we voted it in and we said, go run experiments. So we look forward to new information. If we find a showstopper, we have sometimes pulled a feature out of the draft standard before. I don't recommend that generally, but we have done it before if we found a showstopper. But I'm not currently aware of any showstopper, but that's where we ask people to bring examples and measurements. So we'll look forward, no doubt, at our next meeting, which is begins like 2 days after meeting C++ in Wrocław, Poland. We'll no doubt get more information about that from people who've been doing investigations. To me, the most surprising thing to me, positively, of P2300, I always knew state execution was important. I hadn't followed it closely. I also had heard that, oh, the parallelism folks were working on it as well, and they were excited about it, which surprised me because I thought it was about concurrency. And I know concurrency and parallelism are different things, right? Concurrency, having essentially as if a thread run at its own speed independently of other work, right? Where you're interested in things like, how do I communicate back and forth between these asynchronous workers by messages, things like that, message queues. But it's about asynchronous working. That's what threading is about. It's asynchronous work, whether it's stood thread or something similar. But parallelism is about, I have a single computation I want to spread across a lot of hardware, GPUs, CPUs, to divide up the work, fork join, and get the answer faster, right? That's a totally different model. I am really surprised that std execution really has come up, as much as I've been told, has come to satisfying concurrency and parallelism. I did not expect that we would have a single proposal where I would hear the NVIDIA people saying, hey, we have CUDA examples that are just as fast in P2300. And that I would be hearing the concurrency folks saying coroutines, this is the std execution is the best upgrade to coroutines that we've had, which is all about concurrency. That is the best concurrency coroutines API that the C++ will have ever had. It'll make coroutines more usable. I mean, those are very different things. Coroutines are all about concurrency and isolated work and scheduling work and to run independently. CUDA is all about, and parallelism is all about, let's go wide across lots of hardware and get the answer faster by lots of parallelism. Those are very different shapes of problem. So we'll see. I have not looked closely at std execution. I'm just surprised that both of those people who care about those two domains are excited about std execution. I did not expect that would happen in a single execution environment. So kudos to everybody who's worked on that to get us to this place. Maybe we'll find a problem that we haven't anticipated, but boy, it sure looks promising from what I've been hearing.
Yeah, I think it's quite exciting to have something like that finally be supported in the standard.
Now, having said that, that is one of the exciting features that have already been voted into C++ 26. And yet, when you asked me earlier about what's exciting, I said reflection and safety. That's not a dig against std execution. Like, I did say that there are other cool things as well. And I could be wrong, but I don't think that std execution is like super important as like concepts and modules and coroutines. But I don't see it as being in the same category of C++ 11 changed the way we code to make it an order of magnitude better and clearer, make our code like a huge leap forward in the clarity and beauty of our code and expressing our intent. Reflection will get us there, and safety will help us have confidence with our code. So std execution is still super important. I did not mean to at all. There's other features that are coming in, some of which I'm proposing that we hope to be in C++ 26 that will also be good. It's just rare, like once every 15 years, to get a C++ 11 level of improvement. And that's what makes me excited about 26. I think we actually will have a C++ 11 level of a leap forward of improvement. And then, of course, finish it more in C++29 and onwards and keep adding to it.
True. So when talking about reflection, are you not afraid of people misusing this? And
I know it will be overused. As Bjarne often says, every new feature will be overused. And our job is to make sure it's not too easy to accidentally overuse a feature. You want the simple basic syntax to do what you expect and not do scary things. Yes, it will be overused. Am I afraid of that? No, I'm afraid of not being able to write reflection. I need that feature. There is so much goodness that it will give us. So my fear is not being able to write reflection at all. I'm far less concerned about then we go through the process of learning how we shouldn't abuse it. I don't know how many of you, Jens, were you using C++ back in the 1990s? I can't remember how long you've been at this a long time, but were you writing C++ code in the 90s?
Yes, I started in 98 in high school.
Okay.
So technically I've been using it in the 1990s.
So you were probably coming in just at the tail. I started in 93. So about the same vintage, you and I. You probably were coming in right at the tail end of where people were way abusing operator overloading. Like I remember examples like where people would say window, like my window object plus sign my control as like, oh, let's overload the plus operator to add a widget, a control to a GUI window. Like, no, don't do that. Just do add child or something. Like named functions are great. Just use them, right? And so could people abuse operator overloading? Did they? Absolutely. Did we get over it? Did we learn better? Yeah, nobody does that anymore. At least if you work with anybody who does that still, you have a personnel problem, not a technical problem anymore, because as a community, we've learned better. We've learned how to use it. So any new feature will get overused. And that'll certainly happen here. But I fear not having the feature.
Yeah. So there's a bit of a technical question. If local uninitialized variables are no longer UB, how will they behave? Could you please elaborate a bit on that?
Yeah, so for some more detail, see my blog post from March, the Tokyo Trip Report. It's on herbsutter.com. You should be able to find it pretty quickly, Tokyo Trip Report. And that has links to the papers as well. But the short version is, the implementation is required to write to those bits, but we don't say what the value they write is. So they could write like CD, like hex CD, 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 or something like that, or some known value or bit pattern. And the advantage of doing that is that undefined behavior sanitizers can still be able to see, oh, you really didn't initialize your variable. But because it's required to be an implementation well-defined value, it's no longer undefined behavior. You can't get time travel optimizations. You can't get demons flying out your nose as being legal behavior, those kinds of things. The scariness of UB just goes away. You do pay a little for it because you're doing those rights, but if there's a way to opt out where you can ask with an attribute to have the variable really be uninitialized, so you always have a way to opt out and get full performance back, but it's safety by default. And I like the idea of not writing just 0, because if you just jam in the value 0, because that was another proposal, and there's been things like init_all that have proposed doing that. If you just jam in the value 0, that solves like 75% of the problems, because maybe that's what the programmer intended and they didn't realize their int was going to be 0. But there's still a large minority, like 20-25% of cases, somewhere in that range, where that's still not a program meaningful value. So A, you've changed one bug to another, so it's still a bug. But B, now you've hidden the problem from your sanitizer, who can, at the runtime sanitizer, because if they don't see the source code and they're just going by the value, they're going, look, oh, look, an int that has a 0 value. Yeah, that looks plausible, and they can no longer easily tell you. Whereas if you jam in a value like hex CD, 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 or something like that, the UB sanitizer can still look at that and say, excuse me, you're using an uninitialized value here. So we're still not defining in the standard what the value is. We're not saying it's 0, because I think that would actually be a worse result, to suddenly backport, to suddenly retroactively change the meaning of your code. That wouldn't be good. but we are making it no longer undefined. The new term is erroneous behavior, where we're giving it a well-defined behavior that is still considered an error. You still wrote a bug.
Yeah.
You should not have done that. Sorry, it's partly our fault because we let you, but we're gonna make it more diagnosable and not UB, no time travel, no nasal demons, no formatting your hard drive, which is a big improvement, because that really does help also kill some of the exploits, the vulnerability exploits that people are writing with uninitialized variables today. Like, for instance, I give an example in my CPP-Con talk. I may have time to give the same example at Meeting C++, where just an array on the stack. You call one function that has a stack array that contains a secret, and then you return from the function, so the stack memory is deallocated, the stack frame is deallocated, but the secret is still there in the bits. And then you call another function which has an uninitialized variable, an uninitialized stack buffer that overlays that secret and now can read the secret because it didn't write to it. That will no longer be possible in C++26 because it will write something to those values. So you won't get the secret disclosure, the information disclosure vulnerability. So I love that it's a model where I just recompile my existing code with a C++26 compiler and it's safer. That is exactly what we should be striving for.
Yeah. And I think that's a good thing. And especially, like, we have tools in the language to, you know, say this is an error and we don't have a value to signal that, then you can use an optional. There's SCD expected to deal with errors and handle them. Recently seen a blog post on how to use exceptions with coroutines, which is something which is not like really how you should do it, or like, you know. And then on the other hand, we have like a feature which is called contracts. And how's it doing? What are your thoughts on contract-based programming in general?
So first of all, I don't know that we've decided yet whether it will be a TS or it'll be just brought into the standard. I think there's a lot of people working hard on still trying to bring basic contracts into C++26. So we'll have a lot more information at the end of the Wrocław meeting next month as to how that's going. It's currently iffy. There's still I could say 50-50 as to whether it may make it into C++26. But we'll have that discussion about whether to do that or a TS or something as well. But contract-based programming in general it's a good thing. But the main thing I would love people to know is that when we have this discussion about government agencies recommending using Rust or C# or Go instead of C++ because of safety, contracts has nothing to do with that. It is about safety in the sense that it's about functional safety. It's like making your program have fewer bugs, because the word safety is overloaded. So functional safety, meaning I have fewer bugs and unintended behaviors in my program in general. That's what contracts are about, is about finding bugs and having fewer bugs. But it has nothing to do with the benefits people want to get from a memory safe language. So programming language safety is about giving guarantees. And that's like, oh, you can't get a bounds error because all bounds checks, bounds subscripts are bounds checked. Like, that's a guarantee a language can give you. So Rust can give you some of those guarantees. CPP2, CPP front currently gives you some of those guarantees. Contracts are still good, but you just write them individually on individual lines of code. You opt in to saying what you expect state to be. By definition, writing an annotation here and an annotation here doesn't give you a whole program guarantee, but it's still super useful for finding bugs in your code. So for what's sometimes called functional safety. So it's just important to say, hey, contracts are good. I'm all for them, but they're not part of the answer for the government agencies who say use Rust instead of C++. They're not part of that answer because, I mean, just look at it. The other languages that are being recommended instead of C++ don't have contracts either, nearly all of them. In fact, I'm not aware of any currently widely used commercial language that has contracts. So, and let me qualify what I mean by there. No, I don't count Ada. No, I don't count Eiffel. Those are not widely used commercial languages. They're not bad languages. They're just not widely used commercial languages. C# had code contracts. They no longer support that. They backtracked from that. So when you look at the widely used commercial languages, like Rust, I think has a contract proposal. My understanding is it's not pervasive or fully integrated or supported yet. So contracts are good. I think it's realistically, as an industry, we're still figuring them out because like no commercial language, no widely used commercial language supports them yet. So we're still figuring out how to make them work. Probably the number one question I get from privately from C++ compiler managers across the industry are, contracts look great, but how do we know that they'll succeed this time when they haven't succeeded the other times we've tried this in the past? Because this is not our first time trying contracts in many languages. And I think that's a valid question, and I've passed that to the subgroup SG21 to please answer that. I have not seen a succinct answer yet, but maybe I missed it, so I'll keep pushing. So do view it as somewhat experimental in the sense that we hope to succeed where others have not yet, but I think still useful. But it's quite separate from the memory safety problem that has nothing to do with programming language safety guarantees. It has everything to do with debugging my code, finding bugs tactically, and being able to get functional safety of the kind where, okay, I've reduced the bugs in my code, but that's not the same as programming language memory safety, which is about whole program, whole language guarantees.
Cool. You're almost on the last question. Any chance of having type erasure in MSVC be re-implemented, not on top of RTTI? Unfortunately, the current implementation makes it unusable in places where similar names are left behind by RTTI.
That sounds like a great question, and I don't know anything about that situation. So this is new to me. My uninformed knee-jerk reaction is, I don't know how to implement std with and type erasure without RTTI. I mean, you need to know what type you got. And if you're not using dynamic cast, then you must be doing your own type tagging. And I've seen many attempts to do your own type tagging. And then you have to worry about, how does that work with DLL boundaries? Can you combine shared libraries with type tags? So those are the usual things that come up. So, but I have not tried. Maybe somebody knows a way to do it. I just would have expected that dynamic cast would be the way you implement type erasure, just because maybe I don't get out enough. I'm not familiar enough with the standard way. And I know the type tagging approaches that try to roll your own are basically trying to roll your own replacements for what's in a compiler in the standard version. And they can sometimes get benefits that way. Like we know our dynamic cast in Visual C++ is slow. Like we know that, and we want to improve that, as I mentioned, when we can take an ABI break I mentioned before. But yeah, I kind of just assumed that you kind of need to do that to do type erasure.
True. It's like this is out of your hands, I think. That's
yes and no. But go ahead, read the question.
So what happened with the official publication of the C++ 23 standard from ISO, or by ISO?
Yeah, it's on its way. I was told just last week that that it's now proceeding to publication. I've heard this. There's been like 8 rounds of editing, but I'm told that it should appear in the ISO store like in the coming weeks, finally. And of course, they'll probably put a :2024 behind it, but we all know it's C++ 23. The same thing has happened with the C standard. The 23 C standard is likely going to be 2024. I'm just glad it's this year. ISO has never been this slow at publishing standards. We've usually been able to get them published the same year we completed them in the working group. But ignore the number at the end. It is, in the industry, it is C++ 23, because that's when WG21 finished technical work on it and the national bodies approved it. And the rest was just editing delays. And I think I'm hopeful it's a one-time thing. There were some changes at ISO where suddenly everything got glacially slow. I've never seen it take this long to go through a publication cycle. And it's not just us. It's all programming language standards. It's all of JTC1, which goes beyond programming language standards. It's all technical committees. I know they're working on it, but in the meantime, we know what 23 is, and we're hard at work on 26. And it should the official publication should be out soon, but we already know what the standard is.
Yes, so let me drill down on a specific thing you just said. What is the editing which ISO is doing on a finished standard?
So it is editorial stuff. It's not technical stuff, but it's things like fonts and margins and what boilerplate you put in the top, whether you number your subclauses or not. Are bulleted lists allowed to have numbers? We need to be able to refer to things. So we always numbered everything, and they say, well, you can't have numbers on bulleted lists. Okay. And we have a 2,000 page standard. So this is a lot of work. So thank you to all the editors for doing the best they can to keep track of all these. But you go through one cycle and then you send in something that addresses all those. Then you get another cycle coming back. Okay, here's more things we noticed. And it just, and each of these takes weeks or sometimes a couple of months. So it's frustrating for everybody, and I know ISO is trying to improve it. We'll see how it goes, but it is mostly editorial things. Occasionally we get a request that is editorial, and we have to point out that no, that's not editorial. That changes the meaning of our standard. Like, you can't tell us to use capitalization for code examples. Like, then the code examples don't mean the same thing anymore. You can't tell, no, the capitalization is important. You can't tell us to, and even something as in a regular text paragraph, to change something from code font to non-code font can be a meaningful change as far as the standard goes. It can be a technical change. So a few of those editorial seeming changes, oh, it's just a font or just capitalization, we have to push on as like, no, we can't do that. That actually changes the meaning of the standard. But most of them have been just editorial. It's just that there's been a lot of them and that the cycle times have been long. So it's part of how the sausage gets made.
I have heard from book authors that, the editorial stage of their books has actually then introduced errors into the book. And I mean, an error in the book is like, okay, but like if ISO like by accident changes the meaning of the standard and then writes it in stone, we have a problem, right?
Yes. And then, if that happened, everybody would know that's not what was meant, and we'd have to issue a defect report. But it's just, you try to catch as many of them. So anyway, the long story short is ISO has just been proposing more edits than usual, and they've been taking a bit longer. There've been a few cycles, and I know ISO is working on trying to make it better again, like it used to be.
True. Let me bring up one more thing. One second. Yes. Okay. So I thought we have 5 weeks until we see your keynote. And I heard good things about the rehearsal at CPPCon. So what can we expect from your keynote? What are you planning to speak about?
So I plan to speak and to go into more detail on several of the things that we've touched on repeatedly here. Safety, including the example of making what it means and how it works to make local variables uninitialization not be undefined behavior in C++26. So I'll go into more detail than we could go into here about that. Compile time reflection with lots of examples, including examples that work today on the prototypes. And I actually think I don't have any CPP2 code there, because I'm actually showing how to write it in the draft standard, or the soon-to-be, we hope, draft standard syntax, which may be a little uglier sometimes, but I'm willing to live with that as long as I get the feature. And how both of those help us to simplify how we use C++ and how we do tooling for C++. So it comes back to tooling as well, which we touched on. So many of the same themes that we've just been talking about for the last 90 minutes will be coming up, but especially safety, reflection, and then simplicity and tooling, how those both affect simplicity and tooling, but double clicking on that and going in a bit more detail on those things with plenty of code examples.
Sounds fantastic. I think with that, we can close our conversation. It was really a big honor and loved all the questions. Thank you to the audience, and especially thanks to Herb for spending his time with us.
Yeah, thank you everyone for the questions. They're really good questions, high quality.
Yes, very happy with that too. Few questions. It's just there's always some questions falling between things. So sorry if we didn't get to your questions, but I think Herb is now ready for lunch, and so
it's evening where you are. It's lunchtime for me.
Yes, and that was one of the reasons why I chose to have your keynote on the Friday evening, because I thought it's much better for you to be keynoting in your time when you're just still being jet lagged, and not like being like early in the morning or some time in the afternoon in the twilight. So really looking forward in 5 weeks to be again with you on the same stage.
Well, me too. Thank you again for having me here and there.
Yes.
Looking forward to seeing Meeting C++ in person this year.
Okay, then I guess that's it for tonight. And so
have a good night, everyone.
Yes. Bye. Good night.